Hello wonderful person, this is Anton, and today we're going to be discussing a discovery of a very bizarre star system that's literally inside out. Or basically its architecture seems to be exactly the opposite of what we expect or what we have right here in the solar system. And since for decades astronomers used the solar system as a kind of a blueprint for other star systems in the universe, here this particular discovery really doesn't make a lot of sense. And so in this new study led by Thomas Wilson and the international team you see on the screen, researchers discovered a system referred to as LHS 1903 that completely breaks all of the rules. And specifically the rules that we thought apply to all star systems. So for example, small rocky planets like Earth should be tucked away much closer to the Sun, while massive gas giants like Jupiter and Saturn should be slightly farther away, but not too far. And that's because the farthest objects would probably contain even more material that can exist in colder conditions, while massive gas giants like Jupiter and Saturn should be much farther away in the outer reaches of the star system, where the conditions are much colder. And so for many decades, this was assumed to be a kind of a standard. And a standard based on the way we think planets form. Or in essence, that the radiation from the star tends to blast away gas away from the center, leaving the inner worlds predominantly terrestrial, while most of the outer worlds reside in perfect chilly conditions, where they can actually hold on to very thick atmospheres and grow larger and larger for millions of years. And so let's talk about the study and all of these discoveries, and also discuss certain other star systems that even today still don't make sense. But I guess let's start with the discovery and what kind of a star this is. And so LHS 1903 is one of the most common types of stars in the galaxy. It's a red dwarf. And it's located in the thick disk of the Milky Way, where we basically find most stars. So this is as average as it gets. And so here, by using observations from the TESS telescopes, but additionally from the Cheops space telescope as well, researchers identified 4 independent planets. As always, this was discovered by using the transit method, which involves observing the shadow of the planet passing in front of the star. But this star contained 4 planets, which already actually makes it pretty special because multiplanetary systems are always super exciting. But in this case, these shadows only show us the size of the planet. They don't really tell us about the mass. And so by using additional observations from the Cheops space telescope, scientists were then able to measure the mass and determine the overall density, which presented scientists with a very strange sandwich-like configuration. The planet that was the closest to the star was a very small rocky super-Earth, orbiting every 2.2 days. But here it does have relatively high density of 6.8 grams per centimeter cube, which is technically higher than Earth. And this can only be a rocky planet. Then we have our first gas giant, some kind of a Sub-Neptune with a thick gaseous atmosphere, very likely involving water, hydrogen, and helium. So this is a kind of a gas dwarf. Okay, so far so good. Then the third planet is once again a Sub-Neptune and seems to be the least dense planet in the system. In that sense, so far it seems to mimic the solar system, but it's the last object that makes no sense. The fourth planet, LHS 1903e, is once again a rocky planet, with a very high density of 6.1 grams per centimeter cube, which once again indicates rocky surface and very likely thin atmosphere or even no atmosphere. And that's the strangest structure we've seen ever. This creates a kind of an inside-out problem, because in this case we don't expect this planet E to be terrestrial at all. As a matter of fact, it should contain even more gas, as it's the farthest from the star. But instead we have this very dense rocky world with no significant atmosphere. Moreover, in terms of the size of different exoplanets, here researchers also discover an extremely rare planet that fits into something known as the radius valley. Or basically a planet whose radius is anywhere between 1.6 to 1.8 radii of Earth, only a handful of which have been discovered so far. And that's because most of the planets we find are either much smaller or much larger. But that could actually give us maybe a hint on how this planet formed, or exactly what seems to be happening here. And that's because at least one explanation suggests that maybe there was some kind of an atmospheric escape. Basically, the star's heat boiled away the planetary atmosphere over time. And the planet might have been a gas giant before and potentially had thick atmosphere, but it eventually disappeared. Except that in this case we're talking about planet E, the one that's the farthest from the star, which might have not even had any gas to begin with. Which now presents the scientists with maybe a new mechanism referred to as gas-depleted formation. In this proposition, planets might have actually formed one at a time instead of all at once. And so by the time the outermost planet LHS 1903e began to form, the initial protoplanetary disk might have already been quite empty and basically run out of gas. And so it basically did not have anything to form its thicker atmosphere, and thus just remained a terrestrial world. And so essentially here we have some kind of a planet that's a kind of a late bloomer, and might have formed at the end when almost all of the primordial material disappeared. But intriguingly, this particular planet is also located in a region that's extremely close to the famous habitable zone, basically the region where we do expect liquid water to exist. And so the estimated surface temperature for this planet is currently minus 60 Celsius, 140 Fahrenheit. And that means that if it contains certain greenhouse gases, it might in theory even have liquid water. But that's not something we're going to be able to see or prove anytime soon. But based on the study, we can now maybe conclude two things. First, the solar system is just kind of unusual, or I guess rare. The arrangement in our own star system seems to be a kind of an outlier. On top of this system seems to prove to us that rocky planet can indeed exist on the outskirts and possibly form in ways we never expected. So basically here it seems to be all about timing, with certain planets forming late enough where they essentially get almost no material and become sort of underdeveloped. But naturally this is not the only unusual system we've discovered in the last few years, and quite a few other star systems seem to contain architectures we just cannot explain. And so there have been certain other celestial outliers with very strange arrangements. For example, in the system Kepler 20, instead of a gradient, this system seems to be shuffled. It basically features a kind of a big small arrangement, mixing gas giants and rocky worlds, once again in a way that defies the usual distance-based rules. And in this particular case, it's even more difficult to explain. Then we have Kepler 107, where the system has a kind of an inverted density. For some reason, the outer planets are much denser and more iron-rich compared to anything much closer to the star. And here the only explanation that kind of made sense so far involved some kind of a really large collision, and specifically a massive collision that stripped away certain layers from the surface of some planets, changing their density over time. But because we don't really have any evidence for these collisions, right now this is just an assumption. Then we have systems like TOI 178, and this one is bizarre because of this very strange rhythmic pattern where 6 planets seem to orbit in a perfectly synchronized Laplace resonance. But despite this perfect synchronization, their densities seem to be more or less scrambled. Basically, some of these planets are very low in density and are essentially fluffy worlds, whereas other ones seem to be very dense and very rocky. But exactly how they formed and how they created this perfect resonance is currently unknown. I think there's an older video in the description that talks about the system a little bit more. And last but not least, we have HG 3167. In this system, some planets seem to orbit over the star's equator, while others orbit over its poles. Or basically they seem to orbit at right angles. And here they seem to create a highly misaligned and somewhat chaotic architecture, which is practically the opposite of the system I just showed you previously. And so here once again we have something that's very difficult to explain and seems to involve a mixture of densities, but also a mixture of orbits. But all of these discoveries basically tell us that even today, we're still very much in the early days of understanding how exoplanets seem to form. And so trying to base everything on the 8 planets we're familiar with may not be entirely correct. But with over 6,000 exoplanets confirmed and over 10,000 being candidates, right now it's becoming pretty certain that the entire galaxy, and basically the entire universe, seems to be much more diverse and much more chaotic than we ever thought. And so it turns out that the nature has way too many ways to build a star system compared to the standard model we previously believed. And I'm sure we'll be discovering even more of these bizarre star systems in some of the future studies. Until then, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access and a few more things. You can also support this channel by buying the 1 in 4% t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.